So what is BIM? BIM is a graphical model that also has a database attached to the back end, documenting all of the different objects inside. Here we can see, as we spin around this building, we can see the end result of the exterior of the model, and we'll turn off some of the layers so we can go inside and look at the kitchen, which is what we care most about. So we'll turn off some structural columns and some walls. 1 second, and then we'll let the image regenerate. We'll zoom in and we can see the different kitchen objects that we have modeled. Now we don't just do this for the picture, because the kitchen objects hold also information which we will use in our schedules and tags. You can see it's a lakeside, it has a cost, other things, so that we can use this information obviously for a number of different things later on. Here's the tagging part, which ties directly into our schedule, and we'll show that this table has a tag with a certain value. It's 40, and if we change the value either in the tag or here in the properties of the table, we'll see the value changes not only on this drawing, but if we had any others open, it would change everywhere in the project. So quite useful for quality control, having everything tied together. We can see mistakes in a number of different places and track them down to one place instead of having to manually go through everything. So here's the schedule, and this is generated from the equipment we're seeing on the left. And this EquiHeat banquet carter, number 69, will show it. I can go find it from the schedule anywhere in the building, and then also go check all of its equipment to make sure all of the numbers are correct and information that I need. After we have that done, as we can see, we have a 3D view of the kitchen, so we can also use it for presentation and normal graphical niceties. And we don't have to update it in 2 different places, such as like a SketchUp model and then AutoCAD. When we're done with this, we can export it, and that'll be in our next phase, and this is another program which we'll use for clash detection. And here we have the Navis model. The different colors represent a different trade, 1 color per trade. We have the magenta is mechanical, we have plumbing, pressurized plumbing, gravity plumbing, electrical, and the yellow is our food service or remote refrigeration lines. You can see we have gravity hangers, and we'll zoom in and you can see how tight it gets. And we use this to coordinate between the different trades before we get out into the field and have costly errors such as holes in the deck that we can't use, or collisions between the different trades, and having to redesign in the field. So here's our clash detection, and we'll get our different trades together, and so we'll clash against the refrigeration piping and the mechanical. I have it set up previously, so once we would hit start, we go to the results, and it shows us a camera view of every clash. And this is a clash between that strut down below and this access region, which we can see here in solid. There's another clash between another strut and the same axis, and I've approved these because in this case I asked the other trades if this was acceptable, and this also allows us to have a record of what happened so that no one has any questions. So you can imagine how much easier it is to change things in the computer virtually to make sure that we have everything worked out before we go out in the field, instead of being in the field and having crews stop, wait, move, schedule, get in other people's ways, tear things apart, such as in this case we were able to avoid all of the beams with their fireproofing, so we had no back charges.